In this video, I will show how to solve a practice problem on Kirchhoff's laws with three unknown currents using a shortcut method. As you will see, this method is fast and gets you the answer in 1 or 2 minutes, whereas the traditional method involving loop and junction rules take much longer. If you haven't seen my video where I explain the shortcut in detail, when it works and its limitations, I recommend watching that first. The link to the video is in the description below. Let's begin. Here's the circuit I will solve, and the goal is to find the three unknown currents in the three branches. I will call the branch on the left branch 1, the one in the middle branch 2, and the one on the right branch 3. I will call the junction marked by the red circle junction A. The point of the junction is to define the positive directions for the three unknown currents. So I assume the currents I1, I2, and I3 in the three branches to all flow upward toward junction A. The junction A also defines the positive direction of the EMFs or voltages of the batteries. Let's look at branch 1. Here, there is one battery with EMF of 3 volts. Because its positive terminal faces junction A, I set the net EMF in branch 1, which I call E1, to be positive 3 volts. There's no resistor in branch 1, so the net resistance in branch 1, which I call R1, is 0 ohms. In branch 2, there's no battery, so the net EMF in branch 2, which I call E2, is equal to 0. Branch 2 has one resistor, and its resistance is 2 ohms, so I set R2 to be 2 ohms. In branch 3, there's one 5-volt battery, and its negative terminal is facing junction A. So the net EMF in branch 3 is negative 5 volts. There are 2 resistors in this branch, and their resistances add up to 7 ohms. So I set R3 to be 7 ohms. I can now use the shortcut equations, which I explained in the video I mentioned earlier. Substituting the values for the EMFs and resistances into the first equation, I find that I1 is equal to 2.6 amperes. Because it is positive, the actual direction of the current is upward and toward junction A. Using the second equation, I find that I2 is equal to negative 1.5 amperes. Since it is negative, it flows downward or away from junction A. Lastly, using the third equation, I get negative 1.1 amperes for I3. Because it is negative, it flows downward or away from junction A.